So welcome all to today's discussion. Welcome to the University of Cape Town's Chemical Network. If you're just joining, please do continue to introduce yourself with your name, country, and organization. And also, you can see on the screen, we're trying to see the sectors that are being represented. So please go ahead and click on the Minty link and indicate that. I'd just like to welcome you again to our discussion forum. If you're new with this community of practice, it is run by the Division of Environmental Health at the University of Cape Town in South Africa and funded from Sweden through the Swedish Chemical Agency. I am Professor Andrea Rother. I'm head of the Environmental Health Division here in Cape Town, and I will be your facilitator for today's discussion. I'd like to also introduce Dr. Natasha Lalou, who's in the background, who will be supporting this discussion today. And again, if you're just joining, please do introduce yourself in the chat. It helps the presenters to know who you are and where you're from. So the discussion forum is really meant to bring together representatives from different regions, sectors, and stakeholder groups to foster a mutually supporting consortium where we can discuss various issues related to chemicals. And really what we try to do through this community of practice is to build the capacity of regulators, researchers, NGOs in low and middle income countries, and to discuss emerging issues. And you'll see that with the topic we have today, where we're looking at climate change and chemicals interlinkages. So we really hope to build this capacity with members through learning from each other, sharing information, data, identifying gaps, and problem solving collectively. And really with a view for preventing chemical poisonings and environmental contamination with a view to a toxic-free future. This is not a webinar. This is really meant to be a discussion. And so the discussion will be taking place in the chat. If you have any questions that arise during any of the presentations, please put them in the Q&A at the bottom so that we can specifically respond to those. This is a non-partisan group, which means we may not agree with each other's opinions, but we will respect each other's viewpoints. Again, as I said, it's not a webinar, so we won't be taking any participants' hands. We ask you to have your discussion in the chat, but we will have presenters who will have their videos on and speak. So we have 3 presenters today where we're looking at identifying and addressing the impacts of the interlinkages of chemicals and climate change. Could I have the next slide, please? And I will just be giving a very brief introduction to the discussion, and then I will be handing over to my esteemed colleagues from the United Kingdom Health and Security Agency, which will be Raquel, Tom, and Hayden, and I will ask them to give more detailed introductions of themselves as we proceed. Next slide. Next slide. So really just to set the stage for the discussion, I want to draw your attention to a policy brief that we've been working on. It is nearly ready for distribution. I can see it's cut off where on the side it should be saying not for circulation. This is still the draft and should be out shortly. We're in the process of just doing the final edits. But really, this is just to show you the importance of looking at chemicals and climate change nexus, that is the sort of interlinkage. So how are chemicals impacting on climate change? How is climate change impacting on chemicals? And in turn, how is that impacting on health? Next slide, please. So there, as I said, each of these domains is impacting on each other, and the details of this is going to come out more during the discussion. But just to show you the complexity of the pathways of how climate change is impacting on chemicals and then health. So you can see that the various changes in the climate then impact specifically on chemicals, whether it's changing its fate and behavior or breaking down into a more toxic compound, that then is released into the air or spreads contaminations or results in perhaps an increase in use of pesticides and fertilizers, which then humans are exposed to through various pathways, and as well as the environment. So some of these chemicals may then end up in the environment, which again, humans then are exposed to, resulting in various acute and chronic health effects. Next slide. Then, which will also come out and be highlighted a bit more during this discussion today, is the pathways of chemicals impacting on climate change. So obviously, the extraction of raw materials and the production of chemicals, as well as transporting and using it, and then eventually the waste and byproducts impact on greenhouse gas emissions, which then leads to various climate changes involved, such as extreme weather events or sea level rises, and contributing to air pollution, which again then impacts on direct and indirect aspects of health. Next slide, please. So in the policy brief, and what we hope will come out in today's discussion today is to really, these are so two quite separate domains, those who are working on climate change and those who are working on chemicals, and really to have this call to action of reducing the quantity of hazardous chemicals that are being used, but also reducing the impact on greenhouse gas emissions. Next slide. And then the issue that is who takes responsibility? So who actually should be actioning these changes, and calling for an improvement within sectoral collaboration so that these two sectors will work with each other. So for example, you've got the climate change negotiations, and then you have the global framework on chemicals, and trying to bring these issues more in, as well as at regional and national levels, and trying to increase research and data, looking at the intersection between the impact of climate change and chemicals linkage, and looking for opportunities for more legislated changes to ultimately protect human health and the environment. Next slide. So we will be distributing this policy brief shortly, and that was just a brief introduction to set the stage for today's discussion. And I'm now going to hand over to Raquel to introduce herself and take us through to question 1. I can't quite see if you've got your video on. Oh, yes, you do. I've got too many screens.
Hopefully you can hear me okay.
Yeah, much better. Yeah. Much better. Yes.
Fantastic. Thank you.
Thanks, Raquel. Over to you.
Thank you. So I've only got a few slides, but what I wanted to go through is to give you an overview of some of the work that we've been doing in the UK to look at the health effects of climate change. And to that aim, we have produced a report, which was published in 2023. Which looks at the current state, and more to follow in the next few slides. But to start off with, just to introduce myself, my name is Raquel Duarte-Davidson. I head a department that focuses on chemicals and environmental effects. Myself, Tom, and Hayden are in the department, and hopefully between the three of us, we're going to cover a range of topics that link to climate change and health, and the links to chemicals and chemicals exposures. So the next slide just gives an overview. I'm sorry, I'm just waiting for that to show. Yeah, okay, so this it just gives an overview of what we wanted to achieve through the production of this health effects in climate change report. So basically, this is done on a regular basis, and I'll say a bit more on that in the next slide. But basically, what the aim of this report is to update the scientific evidence base that we have on climate change and health. And the aim of this is to inform policy making by government, UK government, because it's a UK-focused document, but also to inform local authorities and other public health partners across the UK. So the key thing is to identify those gaps in the evidence, in the scientific evidence, but also to highlight future climate change research needs, i.e. based on the gaps, what should we be focusing in coming years to try to improve the knowledge in terms of depth and breadth that we have on this topic area. Another key area is to raise awareness of the risks of health effects of climate change and to prove our understanding on the benefits to health. So it's not just all negative, but also look at some of the benefits to health from net zero policies. So on the right-hand side of this slide, you can see the front of the report, the front page of the report, and basically it covers a number of topics. In total, we have produced this time around 15 chapters, which covers a range of health impacts. It took a long time to produce. I was one of the editors. There was 4 editors involved in this report. But we have 15 chapters covering the breadth of health impacts issues that relate to climate. 90 authors from academia, industry, and government participated and wrote contributed to the chapters. And also we had all the chapters peer reviewed by at least 2 scientific experts in the area to ensure that the information presented was accurate. The next slide gives a bit of history in terms of where we've come from and why we produced the Health Effects on Climate Change report, HEC. And as you can see in this slide, it's been something that's been happening for many years. This edition is the 4th edition of the report, and we've been trying to produce them on a regular basis. The first one being in 2022. And in theory, we aim to produce them around every 5 years. So we had another one in 2008, 2012. And we did have a bit of a gap because of the extensive need to update and increase the number of chapters that we covered in the report. So the latest one was produced over the past 2 or 3 years, culminating in its publication in 2023. The main reason we do the report is because we have to do it by legislation. So in 2008, we had our Climate Change Act, and in that, what it highlights is that we need to periodically undertake a climate change risk assessment. So we've done a number of them, and we're now working towards a climate change risk assessment 4 to be published in 2027. And also we have what we call a national adaptation program. The last one was produced in 2023, and within those programs, so the previous one to that one, we said we would publish the 4th edition of the HEC report, and now in the 2023 National Adaptation Program, we said we will update it in the next 4 years. So this gives you a bit of history as to the reason. So really we are committed to climate change and health, and we have a very detailed program to ensure that we continue to gain knowledge and take action on different aspects of climate change. The next slide, please. So this next slide shows again the topics covered, and it's a bit bigger, so hopefully you can see it. As I mentioned earlier, it's 15 chapters, and here I've highlighted 10 that have chemicals in the chapters, or they have a link to chemicals. And as you can see, it covers quite a range. But when you look at the first chapter I mentioned here, temperature, well, temperature has an influence on how chemicals behave in the environment. And I know that Tom will be mentioning this later on, so I won't go into detail, but there's a chapter on temperature that impacts on chemical behavior and ultimate effects on people, on the population. Flooding is another one. So flooding may lead to increased rainfall, movements in the environment, etc., and will have an impact on again, the exposure of people and the wider environment to chemicals. I think you're familiar with indoor and outdoor air pollution. So the changes there caused by climate, and again, the impact on chemicals in the indoor and outdoor environment. Food has an impact as well. For example, we're seeing changes in patterns of pesticide use, for example, and that might lead to and changes in climate may mean that we need to use different pesticides with more frequency, etc. So that could lead to impacts on the food we eat. Wildfires, they're increasing, and of course, a consequence of this is the release of chemicals through these wildfires. Drought is another one. So drought causes, again, changes in the way that, for example, the soil is affected by drought, and that may lead to changes in the availability of chemicals in the soil and, of course, in other environments as well. Then the chapter that we have in this report is on chemical exposures. And that one, all of us online today were co-authors of that chapter. And it's the first time that we've included a chapter in the HEC report on chemicals with the aim of reviewing the evidence. And I know that more will be said later on this one. And finally, net zero. Which is another chapter that's quite cross-cutting. And what we did is we looked at evidence of changes in, industrial use of chemicals, for example, as we moved to net zero, we introduced technologies, etc. And what we found in this chapter is there's very little available in the literature on net zero and chemicals, which is something to note, I guess, but very, very little was found. Last but not least, there's a chapter on indicators, and that is looking at indicators that we can use to see how the environment changes with changing in climate, and of course some of those indicators link directly to chemicals. So all these chapters show you that there are many different hazards that will lead to changes in behavior of chemicals in the environment and ultimate exposure to people and on the health of people through those linkages. So if we move to the next slide. This is just an example of some of the data that we found. And I just mentioned this one because it's looking at temperature. And as you can see, the view as we move forward is that temperatures are going to increase, whatever scenario we use. And really, we're looking at the warmer temperature increases. And you can see that there is an increase in the temperatures. The UK is getting warmer, the world's getting warmer. And the prediction from these modelling is that we'll have changes, not just will we get warmer as winters, but we'll also get warmer and wetter winters. And then we are aiming to, the predictions are there'll be hotter and drier summers in the future. So there's going to be more rain, more drought as well in the summers, etc. And obviously those have significant impact on the way the chemicals will behave. These projections are up to 2100, and all scenarios will have impacts on health. And the weather will become increasingly variable, and we're already noting this, on a daily basis now in many parts of the world. So the next slide, please. Okay, so here I just wanted to highlight that there is different evidence depending on the different chapters, depending on what topics we are looking at. But so when you look at, for example, the impacts of heat and cold, we know a lot about this, and flooding and vector-borne diseases. The key area that's really lacking is the exposure to chemicals. So there is insufficient evidence to be able to available to do a full assessment, and that's really highlighted and comes out clearly in the chapter. The next slide is a thank you slide. So here you can see the link to all the chapters. So you can, if you're interested, you can look at the chapters in more detail, and it's just a quick acknowledgement and thank you. So hopefully, as I've given you a flavour of what the chapters do and a bit of context to highlight the need to look at chemicals, not just as at the other environmental factors that will impact on climate. The climate will have impact on health. So back to you, Andrea, and thank you for your attention.
Thank you very much, Raquel, for taking us through that. And I hope that participants will go and have a look at the HEC report and the important information that has come out of the HEC report that can be used in different countries for addressing these issues. So we're going to move now to the first question to all of you. So what do you think are the sources of chemical contamination linked to climate change in your country or region, or where you're working? And what are some of the priority issues? So you can respond in the chat. Also, if you have any questions for Raquel, please post them in the Q&A. We will also be having some poll questions, so make sure you're linked in with Mentimeter. So let's just see. So Raquel, if you want, you're welcome to keep your video on and your mic. So people are posting responses in the chat, and you can see whether you would like to respond to any of those. So Debbie has indicated that mostly from the agricultural sector and industrial sector for chemicals in terms of the sources, and Debbie is from South Africa. So we're looking, if this is a new issue for you, you can also indicate that and indicate any questions you have. Sorry, Raquel, back to you, and you'll see that there's Jessica from South Africa has also posted. They're going to come in fast.
Okay, so I know there's a question about, sorry, I'm trying to look at them. What are the sources of chemical contamination linked to climate change? So I think the evidence is very poor at the minute. So, and I think that Tom, and Tom, please tell me if I'm wrong, but I think you're going to give a bit more detail on this in your presentation. So if that's the case, maybe we could wait for that, Tom, yeah? A little bit, yeah. So I think we did look at different aspects. So we looked at, contamination from contaminated land, from agriculture and other sources. We didn't do a fully comprehensive review because there's so much out there and so many issues that would need to be considered, but so little information. So I think that the main thing that we can say is that at the minute, we really don't know what the key issues are. When we look at the evidence, air pollution, indoor and outdoor, are key, and there are things or areas that are really significant in terms of the current levels of contamination, and actually possible decreasing contamination as we move to carbon zero emissions. So and people reduce the use of cars, etc. We can imagine, we can expect those pollution sources to be reduced. However, we're not looking at that aspect. What we're doing in the chemicals chapter is trying to cover things that are not being covered in any of the other chapters. And really, there's very little information, for example, on how consumption, how the production and use of pesticides, for example, will change in the future. So it's a really, really big unknown and difficult to answer. Sorry, I've gone about a long way around to say we don't know the answer yet.
So there's quite a few comments in terms of sources within different countries.
Yeah.
So you've touched on some of those. I don't know if you want to comment. You can see they're from the different countries. And in the meantime, we have also posted a poll. So if you click again on the Menti link in the chat, you can respond to the poll. Over to you, Raquel.
Yeah, thank you. So I think that all the areas that you're highlighting are key, and I think there will be the areas that countries are affected by will definitely be variable. For example, I can see a lot of people are mentioning wildfires and agriculture and areas with contaminated land. We will have a lot of issues with landfill and with contaminated land. If we get increased rainfall, increased droughts, sea level rises, what are the impacts going to be in the behavior of chemicals in those environments? It's really important that we look at that as we come forward. And I think that although our review was done on a UK basis, I think a lot of the information that's coming out really is relevant internationally. And I do think that it'll be really good to look at these areas more, in a wider, more international way. An example I can think of is, for example, what's going to happen with lipophilic substances, like when you look at PCBs or dioxins, etc., mobility of these chemicals. We know there's been a movement and accumulation of the food chain. What's going to happen with chemicals like that with increased temperature globally as we move on, changes in rainfall, etc., etc. So it's a huge area. Yeah, there are hundreds of questions and comments, so I don't see how I can do them all, but I think they're all really valid.
No, you don't have to do them all. You can just highlight a few. I did warn you, it would be fast and furious.
Great.
And you can
Yeah.
see that people are also responding to the poll on the screen.
Yeah.
So if you want to comment on any of those, you're welcome
Yeah.
to.
Yeah. Yeah, I think controlling. So I think that up to now, one thing that I would like to mention is the chemicals have not been really in the agenda. So, the focus, and, rightly so, has been on temperature, on, the death rates, etc., or morbidity, increased morbidity and mortality from increased temperature. There's been quite a lot on flooding and natural disasters, etc. But I think the longer term, the issues, the link to chemicals are really important. So really good that we're looking at it now so that we can see what needs to be done, and so we can worse. So looking at the agricultural side impact of the impact of the chemicals on health, hazardous waste. I think that's key, especially in area. We know that a lot of areas are going to be flooded with rises in seawater, flooding in rivers, etc. So what's the impact on those? I think that all of the points here are really valid, and it'd be great to have a more detailed look at these after today as well, I would say. Yeah.
Thanks. And they're
So
still
agriculture,
posting
policymakers'
things.
responsibility. Yeah.
Sorry, go ahead. No, carry
Yeah.
on. Carry on.
Yeah, I think the influence in policymakers is key because at the minute, policymakers don't view chemicals as an issue. And, today it probably isn't an issue, but I think that we need to have that information. We need to at least get a better understanding of what are the predictions, and therefore trying to influence policies as we move forward to reduce the longer term impacts. And the economy and trade, that's definitely a key one that often drives policy and what we can do in the research field as well. Yeah. Okay. Yep, quite a few on policy there. Yep. Don't know whether you want me to carry on, Andrea, but
Yeah, so we're going to move on now to poll
okay.
2. And just to say that in the chat, the people are still continuing to list sources of contamination. So from coal stations, from agriculture we've had, you'd mentioned pollution, burning. There's also waste dumps. There's quite a good and long shopping list happening. We do have the next poll on the screen. What are the implications of increasing climate events on chemical exposures? And really, again, for you to capture the thoughts, it helps if you put your country in the response, and you can click on the same Menti link to respond to this. And thanks for everyone who's been so active. Back to you, Raquel.
Thank you. Yeah, so I'll wait to see, but this is it'd be really good to get a feel for what you all think on this one.
So there is a
And
question from
Yeah.
Nanette for you. I'm just trying to read it. So she says, I understand correctly, this report covers how climate change impacts chemicals, how chemicals act. What about the other way around? I think she may have joined a bit later when we talked about some of it, but so how broad spread use of chemicals actually exacerbates climate change, causing erosion, harming ecology, etc.
Yes, I think that's an important topic that needs to be looked at as well. So as a good example, increased pesticides or overuse of pesticides. What are the impacts of those on soil quality? Even increased rainfall will lead to increased soil erosion. Floods and droughts will have opposite impacts, and that will impact the soil which in turn may mean that it's more difficult to keep a healthy soil and to ensure that we have the appropriate fertilizers and pesticide use, etc. So I think, again, I think because the gaps are so big, what we have done is try to focus on specific areas and try to see what those gaps are. But I think you're right. We need to look at the whole if we can, and try to set an agenda for what we need to look at in the future. So one of the things that we're hoping to do in tail end of September is to have a workshop to look at further at the evidence and maybe try, and Andrea, I know that you're involved with that and others online, so try to sort of get a feel for what the key topics areas are in terms of gaps in evidence. I think that's the key that we're focusing on very much. And not only gaps, because I think we know what the gaps are, but which are the ones that we should be looking at and focusing our research now to try to answer those gaps. And I think we move to the next question on the poll, have we?
Yes, we've moved to the third poll because we're going to finish up question 1 shortly.
Brilliant.
But I think you've been highlighting some, key points. It's interesting if you look at the chat. I think there is quite a lot of knowledge.
Yes.
But there isn't a lot of joint effort and work on addressing this issue, which is what you were highlighting, and hence a lot of gaps then. Yeah.
And I think that's the thing we need to look at, isn't it? And I think between all of us, and so one option is to, through this network, or maybe have a sub network. I don't know how we would organize that, to maybe start engaging more on this, communicating these issues. And for example, Tunisia having higher temperatures will definitely increase the volatility and degradation and movement of chemicals. And that's the thing, it's not just, will the chemicals move, and what will happen to the chemical? But will they degrade? If they degrade, what to, and what effects will that have on people and the wider environment as well? So yes,
just
quite a lot of really good, sorry.
Sorry. No, I see people. Oh, there we are. People are responding to the poll, but the options weren't defined. So they've now been defined. Yes, no, and don't know. So I'm assuming everyone thought the first one was yes. But back to you, Raquel. Sorry about that.
So on the poll, do the government departments in your countries that regulate chemicals or include issues related to climate change? It's really good to see that at least more than half of those answering is yes, although a significant amount are no as well, and there's a few don't know. So it'd be good maybe to try to explore and get further information maybe from those as well. But yeah. It's good to know that quite a few of them do regulate the chemicals in that respect. Okay.
Great. So I think we'll move on to question 2, unless you've got any last comments.
I think it's really nice to have so many comments, and I know it's difficult. I probably haven't answered all of them, but hopefully we'll have access to the text and maybe can comment later on, maybe, Andrea?
You will. So we do produce a digest from this discussion, and you will have an opportunity to respond in the digest, but you can also, while Tom and Hayden are talking, if you want to say anything else, you can type it in the chat. You're welcome to do that. And just to remind people, if you have specific questions for the presenter, to please put it in the Q&A. So thank you very much, Raquel, for covering a lot in a quick, short period of time. And I'm going to now ask Tom to turn on his video and to introduce himself. Can I see Tom? There you are. Hello. Nice to see you again. And please, and thank you for giving of your time. And please do introduce yourself and take us through question 2.
Sure. Thank you for the invitation to join today. And thanks for the introduction by Raquel. It makes my job slightly easier. Now you all know what the HEC report is. So my name is Tom Galton. I'm a health protection scientist in the Chemical and Environmental Effects Department of the UK Health Security Agency. So that's Raquel's department. So I work under Raquel and Hayden as well. What I'm going to be doing is a very brief slide set on characterizing or understanding the risk to humans from chemicals due to climate change. So hopefully I can elaborate a bit on what Raquel has already said. Can we go to the next slide, please? Thank you very much. So, as Raquel said, Raquel, myself, and Hayden are co-authors on Chapter 12, Impact of Climate Change on Human Exposure to Chemicals in the UK. While the HEC report is written for the UK, I think a lot of the issues can be applied globally, a lot of the issues that are discussed, and particularly the themes that have been identified. So, adverse toxic effects resulting from human exposure to chemicals released into the environment can range from acute poisonings and other acute health effects, such as asthma attacks, to chronic effects, such as cancer and immunosuppression. Global climate change is causing major physical and ecological changes in the environmental conditions, increasing the risk of certain health threats becoming more common in the future. So there is a growing need to identify and mitigate potential effects of chemicals exposures and the resulting health impacts in the changing environment. So to meet this sort of knowledge gap a little bit, a literature review was undertaken to look at the interactions between climate change, hazardous chemical releases, and the resulting human exposure. So the review focused on 4 key areas. As Raquel went through the topics earlier, I think it's clear to see that chemicals are involved in almost every aspect of this report. But we limited our chapter to 4 main themes, because these chapters were already covered by other authors. So the 4 main themes include impacts on chemical fate and transport from climate change, chemicals in agricultural settings, chemicals in industrial settings, and chemicals and land deposited contamination. I mean, we went for contaminated environmental media, sort of to be general, but most of the results we had in our literature review refer to land deposited contamination. Okay, and the chapter also highlighted gaps in knowledge and provided adaptation and risk management recommendations for research, policy, and public health. So what I'm going to do now is just go through very, very briefly each of the themes and a few of the things that came up during the review. Next slide, please. Thank you. So here is a graphic which sort of represents some of the things that we'd found when doing the review on chemical fate and behavior in the environment. So this small graphic covers an extraordinary range of things. So very briefly, we found that changes in temperature can encompass changes in precipitation, changes in sea level, changes in UV levels of radiation, the changes in runoff, extreme events such as increased floods or droughts, changes in wind speed, and also erosion. And these wide array of changes can have effects on the mobilization of chemicals, for instance, leaching from landfills, for example. It can change the soil's physical chemical properties, making the soil sort of more or less likely, depending on the chemical, to withhold the chemical in the soil or release it into the environment. It can change the salinity of water, the volatilization of certain chemicals in the environment, and also changes in pH and microbial ecology. The result of all this is that it can have drastic impacts on chemicals in the environment, ranging from dilution to persistence, particularly in soil, degradation, as Raquel mentioned. Some chemicals actually have degradation products which are more toxic than their parent counterpart. The transformation of chemicals and bioavailability. So, for instance, changes in water salinity or pH could increase or decrease the uptake of certain chemicals into organisms in the environment. And this also can change the distribution between different environmental media. So I think it's safe to say the relationship between the changing climate and the effects on chemical behavior is rather complex. Next slide, please. Thank you. The next theme we covered was chemicals in agricultural settings. And as I can see from the messages in the chat, this is quite an apt topic. It seems that many of you have had experience with this or recognize this as a problem. So very briefly, from this section of the review, we found that numerous chemicals or mixtures of chemicals are emitted by agricultural systems. And these can be very varied and quite complex, and can include things like pesticides, fertilizers, veterinary pharmaceuticals, treated municipal wastewater, and feed additives. And climate change has the potential to increase human exposure to these chemicals. And based on the slide I presented previously, it can result in many more chemicals being increased in their use, and many more likely to leach into the environment based on agricultural factors. Additional risks were also identified from this section of the review, including chemical contamination entering the food chain through many sources, such as increased runoff resulting from heavy rainfall events, and may affect food security. And also there's going to be, with higher temperatures, probably changes in rainfall, it's going to be more difficult to actually grow the food that we're used to doing in the ways we're used to doing. So food security could be impacted. And also, there's a risk of using contaminated water for irrigation, which may result as changes in rainfall or precipitation could affect the water supply to these farms. So as a last resort, it's thought that some could use contaminated water. This will obviously introduce contamination into the crops. Next slide, please. Thank you. So next up was chemicals in the industrial settings. So fairly straightforward, populations located close to sources of chemical contamination, such as manufacturing, storage, waste, transport hubs, are at higher risk of being exposed to harmful substances over a longer period of time, and potentially at higher concentrations too. The climate change could increase further exposure to persistent organic pollutants and other contaminants in industrial areas. For example, outdoor air inhalation, transfer to the indoor environment, and emissions to water sources. Temperature rises would be a key in driving, in particular, the increased volatility of industrial pollutants, and temperature rises could also increase their mobilization in the environment, potentially distributing them in a much more widespread manner. Industrial settings are also at significant risk of extreme weather events causing environmental contamination, and flooding is an obvious one. It's not a UK example, but a good example was a few years back in Texas in the US, where some particularly bad tropical hurricanes landed in Texas, and they actually hit an area which was highly populated in industrial facilities, including manufacturing and storage of chemicals. This flooding and damage to the sites caused severe economic impacts and also health impacts to the region. So it's something we have to sort of be looking at as the climate continues to change. Next slide, please. Thank you. So this is the final of the 4 themes that which our chapter centered on. And it looked into chemicals and contaminated land. So climatic changes such as heavy rainfall and increased flooding could lead to the mobilization of hazardous chemicals from storage or remobilization of chemicals already in the environment within contaminated land sites. There's a plethora of toxic substances which exist in these sites, including many heavy metals, arsenic, mercury, lead, cadmium, and chromium, and many other organic contaminants, such as polyaromatic hydrocarbons like benzopyrene, persistent organic pollutants such as PCBs, polychlorinated biphenyls, or polyfluoroalkyl substances, for instance, used in fire retardants and firefighting foam. There are also some of the ones which referred to as forever chemicals. So it's really not a good idea to have an increase in those in the environment. Existing landfills are also vulnerable to climate change mediated leaching of chemicals, for example, from increased flooding. And we've found that updated risk assessments are required. Many of the risk assessments, I mean, this is just the UK, many of the risk assessments for landfill sites in the UK are quite old now, and none of them really account for a changing climate where the risk of flooding could increase over time. And obviously, there are also risks of contaminating the water table from leaching chemicals. Can we have the next slide, please? Thank you very much. As I said before, the issue is extensive and can be extremely complex. So while there is evidence of climate change-driven negative impacts on the distribution and toxicity of contaminants, there is currently insufficient information to provide a full understanding of the interactions between climate change, chemical releases, and the resulting human exposure and health impacts. However, the results do indicate that climate change could increase the risk of human exposure to chemicals through some of the ways we've seen in these slides. Through modulation of temperature, precipitation, erosion, wind conditions, and extreme events. Okay, and in addition, the amounts and types of chemicals stored, used, and transported are likely to be affected by climate change, with potential impacts on exposure risk to chemicals in the future. Contaminants that are anticipated to increase in the UK environment due to climate change include persistent organic pollutants, pharmaceuticals, volatile organic compounds, pesticides, and heavy metals from the sources mentioned previously. And recommendations to protect the public health from climate change-induced exposure to these chemicals include developing methods to assess the potential direct effects of climate change on chemical toxicity and further collection of related scientific data. A key one is the identification of priority contaminants to research the fate of chemicals in a changing climate and the risk of human exposure to them. Finally, a clearer understanding of the actions required to reduce exposure is essential to implement changes in policy. And I think that takes me to the end of brief slide set. Is that the last one? Yes, okay.
Next slide.
I think that's it.
There we go. Yes.
Thank you.
Thank you, Tom. Thanks for highlighting those 4 key areas that were covered in the chapter and giving more details on that, which I think is really important. So we're going to move now into the second question. How do we characterize or really understand the risks from chemicals due to climate change and what this impact has on humans? So if you can give some examples that you're aware of in your country and mention your country in the chat. Also, if you have questions for Tom, for things that he raised, if you could please put them in the Q&A. There are some questions already in the Q&A and Raquel has been answering them. So please do go back into the Q&A and have a look at both the questions and the responses. And I'm just going to have a look. Yeah, Raquel's busy with all 3 questions, so you don't need to answer any of them, Tom.
Apologies,
so
I can't multitask like Raquel, answering and presenting at the same time, so thank you.
Well, no, not typing for you, just talking. So there is a comment in the chat from Jessica from South Africa saying how in South Africa they characterize. I'm not sure if you can see that. I don't know how many epidemiological studies are actually being done on chemicals and climate change, but there's a fair amount being done on chemicals.
Yeah, I'm not aware of many that add climate change into the mix.
Correct. Yeah. So I think quite a lot of the epidemiological studies people are referring to are more about chemicals rather than chemicals and climate change. And that's really, as Raquel was talking about, you know, we're trying to identify where the gaps are. So there's a comment from Sheridith. I don't think we fully understand the extent of which climate change increases the risk of chemicals' effect on humans, which is true.
I agree, yeah. And I mean, with the things we've presented here today, I mean, it was the UK was the sole focus of this HEC report. And while the issues we discussed can be applied to other countries, yeah, it's different countries have different amounts of rainfall, different temperatures, so it's really hard to sort of extrapolate what we found to other countries. It's merely we're just highlighting the issues that we found.
But I think that's important, even though it's country specific. I think it's very important for people to start seeing what the issues are, for example, in the UK, to start looking out for similar issues in their countries. We've also posted the first poll question. Again, you can use the Menti link in the chat. So what gaps do you think there are around trying to characterize human exposure specifically in relation to chemicals, this chemicals and climate change linkage? I think we do have, as I said, research on chemicals, but not so much on the linkage.
Yeah. And to continue from Sheridan's comments, I mean, there's a really good point there. You know, as the increased rainfall washes away the pesticide, the farmer doubles and triples his doses with no attention to development of pesticide resistance and also safe residue limits at the time of harvest. I mean, that's a great example of how chemicals, the use and amounts of chemicals will increase based on this climate change.
So now you have two postings to look at. You have the responses in the chat that continue to come in, but now there are, as you can see, some responses on listing the gaps in the poll.
Lack of data, absolutely lack of data. That was one of the main conclusions from all the chapters in the HEC report. We need more data on this. There really isn't enough at the moment. Difficulties to link chemicals to climate change. Yeah, but with it's particularly hard data. You know, what are the quantitative effects of the climate change on the chemicals? Epidemiological studies, priority pesticides. Yeah. Limited risk assessment models. Yeah, I think the risk assessment model is going to have to be updated to account for changing risks due to climate change. Limited research, yes. Excessive use, ignorance of people increasing the risks. No specific studies rating climate change to release of chemical. Yeah, there's not a lot that specifically link climate change to chemical.
So Jessica makes the comment in the chat that linkage could be possibly shown through modeling techniques, which I think is something that you were also raising.
Absolutely.
So I have a question for you. And I mean, perhaps it's for all of you, is this, so there's a chapter at the end of the HEC report on indicators, and I'm assuming there were indicators that were linked to this chapter on chemicals and climate change. Is there any data that's available for those indicators?
I'm not too sure. We didn't specifically touch on indicators in our chapter on chemicals.
And the indicators chapter, I must confess, I haven't gone through it in detail to see whether there was specific indicators linked to chemicals and climate change.
No, me neither, I'm afraid.
Okay, maybe Hayden and Raquel can indicate in the chat if there's anything.
Yes, if either of you can remember anything, please let us know. Scattered research efforts, fragmented policies. Yep. Some mitigation action. There's not anything action directly related to chemicals because this is very complex. Yeah, I think you know, the more research that's been done, the more sort of clarity and the clearer linkages that are done. I think it'll be an easier picture for people to understand.
Debbie makes the comment in the chat that, or actually asking the question, isn't there a need for a vast amount of data when modeling to ensure the results are correct?
I mean, yeah. I mean, the more data you have, the more accurate your model is. But it depends on which model. I don't think there's sufficient data reached to date. I would agree. I don't think there's enough at the moment. We just sort of there's a lot out there about sort of casual linkages, but nothing really concrete with data to back it up.
Is there anything else you want to say on poll 1 before we move to poll 2?
I think we've covered it.
Nope. Right, so we're on to the second poll for the second question. What information do you think regulators and others need in order to regulate this interlinkage better? So in the beginning, I indicated the impacts from the different pathways, whether it's climate change on chemicals or chemicals on climate change. And then Raquel and Tom have given various details and information. So what information do you think a regulator would need? And would they understand the importance of this relationship? So many of you earlier on indicated that policymakers were key, but what information do they need? You can click on the Menti link again to respond to this question. Yeah, and Hans in the chat is raising the point of kind of an indirect effect as temperatures increase, particularly in African countries, farmers and farm workers won't be able to wear their protective equipment when applying pesticides, which then increases their risk of exposure to highly toxic chemicals, highly hazardous pesticides, and if the pesticides break down into something more toxic.
It's a very good point. I mean, it's kind of an indirect effect in a way, but absolutely, it will have to change the way they use PPE, the PPE that is used. It completely changes the risk. So yeah, very good point. In sufficient reach data on the linkages, policy brief. Yeah. Data showing increase in pesticide use over the years, absolutely. Good data is required to fully understand and give guidance to regulators. 100% agree. Anyways, it's work. That one looks like it got cut off early. Chemicals toxicity on, I'm sorry, it's a bit further up. Yeah, on chemicals like pesticides on water sol. Is that solubility? Okay. God, they come in fast, don't they?
They
Can't keep
do.
up.
Yeah, Natasha, maybe don't move quite so fast, just move slowly.
It's a good thing. Thank you to the participants. You know, it's really good that you're so involved and engaged. Data, more data. Yes. Require the research institution funding. Increased funding will lead to further research. Absolutely. Data on the effects of health and the environment. Yeah, I mean, it needs not only clearer linkages, but data on the health impacts of what these things are doing. Sufficient comprehensible data that links increased use of chemicals to effects of chemical exposures. Yep. Standard procedure to mitigate climate change and chemical application. More research needs to be done on long-term effects of climate change and pesticide usage. More data needs to be compiled and shared. Totally agree. More data is better.
I think the question, Tom, sorry, the question then in response to that is it possible to generate more data? So if there is funding, are there the people out there to generate this data? Or do we need to have more people trained in being able to generate this data?
I think there's a lot of people out there who can generate the data. It's whether they are sort of linked in to each other. And this is one of the really important things about networks like this, is that it's linking climate scientists with chemical scientists, with toxicologists, with environmental scientists to really get a good holistic picture of what is actually going on. So yeah, there's people who can do it, but they might not be in touch with each other or in touch with the right people.
So who's responsible for making that connection, or who should foster that connection happening? Should that, yeah, where does it begin?
It's above my pay grade, Andrea. You're absolutely right. Oh,
Hayden, you can come in, put him out of his misery.
Well, I'll be covering some of these elements with my presentation in a short while. So yeah, there are international agreements, etc., at high level, which are helping to bring together the different sectors, recognizing the role that they all play in protecting health. So I'll mention a couple of those later. And that is actually a really good starting point to have everyone working from a similar point and understanding the broader impact of their work and coming together. So I'll just say a little bit about that later.
Thanks, Hayden. Well, since we are now pretty much concluding on question 2, Tom, is there anything else you would like to say in conclusion before I move on to question 3?
Not really, no. It's just, again, really good to see all the responses and the engagement with the participants, raising some very good points and points which mirror our own that we've made as well. So that's always good. One final thing from the chat: do we need to train more scientists and the networking of scientists? I mean, more scientists are always good, but yes, the networking of scientists, I think, is a key thing to generate these networks, to get people talking to each other, and further get a grip on the linkages between climate change and chemicals. You're going to need more people from different backgrounds. Yeah.
Thank you. Thanks, Tom. Thanks for generating a great discussion, and thanks also to the participants. Yeah, so lots of food for thought. We'll hand over now to Hayden, but if there's anything else you want to respond to in the chat, please feel free to. Hayden, over to you, and thank you very much also for taking the time to present today.
Oh, you're welcome. It's a pleasure. So good afternoon, everyone. My name is Hayden Cole. I'm the Group Leader of Chemicals and Poisons in the Chemicals and Environmental Effects Department at the UK Health Security Agency. So our group has a focus on protecting public health from chemicals and environmental hazards. This includes contributing to the UK's capability for preparedness, response and resilience for chemical and environmental hazards, and for providing evidence-based advice to government to inform policy and health-based decisions. So the HEC report is, of course, part of that. There are broader pieces of work that we do as well around contributing to international work programs as well. So we work very closely with international bodies and partner countries as well, trying to build resilience to chemical hazards and protecting public health. So on to the final question then, I think, in terms of the HEC report. So how could the risks from chemicals and climate interlinkages be managed? I've heard some of the answers. Well, some of this has actually, I think, already been discussed in the preceding discussion. So it may be a recap, and we can discuss it again at the end when I've provided my presentation. The other question is, what is needed to make this happen? So Andrea mentioned that one point about, for example, who is going to own the change that is required. Next slide, please. Okay, so just to recap, the HEC report really, the chapter on chemicals really focused on evidence within the following 4 themes that Tom mentioned. So they were around fate and transport, chemicals in agriculture, chemicals in industrial settings, and chemicals in the land setting, so deposited contamination. That would also include things like waste and brownfield land, which is land former occupied by industrial use. For example, it might be contaminated. So what are the risks from that related to climate change, etc.? Next slide, please. So the review was very much based around, or set out in managing what could be delivered, I think, because there are many settings where chemicals compose or sectors which chemicals may be used in. They may be present in the environment, different pathways, etc. So there are so many factors where chemicals could be a risk. So just to flag some other ones, things like air and flood, fire, etc. These were all considered in the HEC report, but there are some other things, for example, around what the construction industry might generate new risks, etc., from building materials affecting the indoor environment. So how we adapt as a society to climate change might also introduce new risks. So there are, given that the amount of chemicals that we use and new ones being produced every day, what do the new chemicals of the future, what risk might they pose? What are emerging risks? How might we detect them? We might not even know that they are a risk currently, but they might we might identify them as risks into the future. There'll also be chemicals that form part of our new energy technology. So, for example, any chemicals used in carbon capture or energy storage, etc. So it's important those things are also considered. And other factors such as how our diet may change with a changing environment, whether there's adaptation to what we eat might change our exposures. General aspects related to human behavior as well, so spatial or planetary boundaries and our geographical distribution, and some other things such as natural sources of chemicals, so geogenic sources. And Tom gave an example earlier about arsenic. So arsenic is a natural chemical found commonly in rocks and can be leached to groundwater, possibly as a result of climate change that might increase. Next slide, please. So the big question for us in terms of how do we manage the risks, we need to have a good understanding of what the risks actually are. And just to highlight where our current understanding lies, Tom mentioned how there were big gaps in data and what we knew about chemicals, and that did result in a recommendation that we need more information. And just put things into context. So there are already very large gaps in our understanding of the health impact of chemicals. And just to reference a WHO publication around the public health impacts of chemicals, knowns and unknowns, the WHO estimated that there was already 2 million lives lost and 53 million disability adjusted lives lost in 2019 due to the exposures to the small selected chemicals that they used in the study. So that's really that's globally. So this is really a tip of the iceberg sort of thing. So because that was a small number, there are many more chemicals in production and in use, and that complicates things, I think, because it's not possible to keep up with all the chemicals in use. So there are things that we don't know, for example. So in our day-to-day lives, what are we fully exposed to? What is our lifetime expo zone? We need further information to help us identify sources of exposure, what is present in the environment, what is present in the things we do on a day-to-day basis. So it might be consumer products, for example. We need to understand the exposure pathways. So how might we be exposed? Also, how much is too much? How much is going to have an effect? So we really need evidence and data to be able to tie in chemical exposure to the attributed health effects. That's where we were already. And this is also further complicated when we try and assess the effect of climate change on those factors. So I think as an exercise going forward in managing the risks, it may be necessary to prioritize chemicals that we need to either focus on or prioritize specific pathways, etc. Next slide, please. Okay, so going forward, in terms of managing the risk, it's already been mentioned that we really need to build our knowledge base. However, that also creates, in some respects, an opportunity for us to learn more and understand more about our chemical exposures. So a much clearer understanding of the risk and the actions required to reduce exposure really is essential, actually, to be able to help inform us and to develop and improve our risk management actions. So when I'm talking about risk management actions, this includes, it might be legislation, it might be policy, it might be more data acquisition, it might be training scientists on how to collect data, it might be investment in surveillance, etc. So there are large gaps. There is a fair bit of information around the fate and behavior of chemicals, because this has been an environmental science topic for many years now, about how certain chemicals are, well, whether they're present in the environment and what their fate and behavior is. But I think the gap really stems from less is known about also the impact on health, and also certainly what effect climate change might have on that. So there's really a need to look more into what we can do in terms of our predictive models and our risk assessment. How can we improve our risk assessments, and how can we generate more data to help inform those? So we did see that surveillance was mentioned in the chat as well. So yes, surveillance is important. And one factor that we should consider is building better systems, or having better system integration between the different sectors to help improve our signal detection. So for example, this might include an environmental surveillance program, linking and connecting that with a climate change or a meteorological database, and again linking that further with other signal generating surveillance activities, and that will help us identify risks to health better, and also help focus our priorities for risk management. Certainly further work required around the sources, the pathways and receptors. I say receptors, we're assuming they're human health in this instance, but we do need to think more broadly in terms of receptors around impact to groundwater, so drinking water resources, thinking of the One Health approach as well. This is a key to a lot of the way we should be working going forwards, because nowadays we realize that our impact on the environment can affect affects the environment, but it can affect the food we eat, and the cycle continues, for example. We certainly need to know more about the exposure and health impacts of chemicals. So one way that we can do that, and we are doing that, is programs such as biomonitoring. So these can understand the accumulation or the exposure indicators in humans to see what they've been exposed to, etc. And then there's further work to identify what the source is and how people are exposed to that. But that might be a good start. And then associating the actual effect of climate change on exposures. So just because we have someone that's been exposed to a chemical, and they may have been eating a particular food, how can we then, or drinking some water, or doing a certain task, it might be at work, for example, as we've seen in the chat, how has climate change modulated that exposure? How has it made it worse, or could have actually made it less? So there are still gaps there. Tom mentioned knowledge exchange. This is really important. So it is important. This is a global problem. So it's all important we work together to help share knowledge. And this platform is a really good way of doing that. So, and I've already mentioned about how it's important, we think, to identify priority contaminants, to research the fate of chemicals in this changing climate, and to understand the risk to human health. Next slide, please. Okay, so just a couple of examples of existing measures and plans I'm going to present here in terms of how we can manage the risk. This isn't exhaustive, and this really is just almost a top line summary, for example. So there are a number of international agreements, and we're specifically going to mention a couple, but they do focus very much on the climate and the climate effect on health interlinkage, rather than the existing agreements relating to the causes of climate change itself, etc. So I'll mention those in a minute, but we also have national plans and policy. So to give you an example, the UK has the National Adaptation Programme, and within that programme there is a reference to how we might reduce exposure or emission into the environment of chemicals, and that is specifically around the targeted use of pesticides. So, for example, the use of global positioning satellites to help the sprayers get a more accurate spray, for example. But again, will this work? So we've already heard some examples about how farmers have, or we've heard of reports of where people are reapplying pesticides. There are case examples where studies have demonstrated that pesticides shortly after application can be detected in floodplains and water sources after high rainfall events, etc. The next way that we can manage the risk is certainly in preventing the chemicals getting into the environment in the first place. So applying the sound management of chemicals principle throughout their life cycle. Also, other things around the elimination, substitution hierarchy, etc., using less hazardous alternatives. So there is legislation in place which has driven some of that. So particularly in the UK and Europe around what's called REACH registration and the just using various emissions directives about how can we reduce the VOCs in paints, etc., in order to produce cleaner air. So in terms of applying the sound management of chemicals, this comes from the principle on the strategic approach to international chemicals management. On the next slide, I'll be providing a little update around that. But this is about good practice, essentially. So if we can apply good practice, prevent it entering the environment, that should hopefully do what we can to reduce exposure. But I'm mindful that the objectives, or some of the objectives of SciCam 2020, the last iteration, were failed to be met. So we've got more to do there as an international community. There are things being done already in many places, actually, not just the UK, around building resilience around against climate change hazards. So, for example, building resilience to flooding. However, many of those may not have the core intention of reducing exposure to chemicals, perhaps more the damage and the disruption of the floods themselves. So a consideration for us in the chemicals and health sphere would be around how do we build the resilience of sites that harbour either chemical infrastructure, mining sites, waste disposal sites, contaminated land. How do we make them more resilient to high precipitation events, etc., and also soil erosion or water intrusion, for example. Next slide, please. Okay, so a couple of examples of existing measures of public health practice. I want to give you a couple of examples from the UK. So I mentioned surveillance earlier. We have a web-based surveillance system in operation. That's for environmental exposures, called the Environmental Public Health Surveillance System. There's a QR code there if anyone would like more information about that. That is a continuously building and improving system. So it collects data around environmental incidents and exposures, but it also brings in data from the meteorological office, etc. So we may be able to utilize that for climate change impacts. On a similar level, we already have a targeted surveillance program for other climate change related adverse health outcomes. So we hope to be able to build further on those to help improve our ability to manage the chemicals element. And examples of that is around our surveillance for invasive disease vectors, so specifically around mosquito and ticks. And you can read more about those in chapter 8 of the HEC report. Next slide, please. So I mentioned some of the international agreements around health and chemicals, and I really wanted to mention these because these are international for one, and they're something that we should all be aware of. So there's a couple of recent international agreements that do recognise the risk from the climate interlinkages and have committed to action. Specifically, the Global Framework on Chemicals. So that's for a planet free of harm from chemicals and waste. So this is the successor, if you like, of SciCam 2020. So there is specific reference in there that the framework is designed or aims to address the triple crisis for our common environment, climate change, diversity loss, and pollution crisis, amongst the other challenges. So those are, if you like, benchmarks for setting out our commitments to work together amongst those different sectors to help improve health. So that when we want to improve health, we should be ensuring that we're injecting the health argument across all decision-making elements of governance, for example. There is a specific target within the Global Framework on Chemicals for stakeholders to identify and strengthen the synergies and linkages between chemicals, waste management, and other key environmental, health, and labour policies. And that does include climate change solutions. The other thing I wanted to mention was within Europe, at least, we have the WHO European Environment and Health Process. So again, within that ministerial declaration, countries have committed to prioritise action on the health challenges related to what we refer to as the triple crisis of climate change, environmental pollution, and biodiversity loss. And a long-running theme within the environmental process has been the strengthening of engagement between the health sector and all the other sectors. So, for example, transport. Next slide, please. That's it. I think I just wanted to put that slide up for further information in case you wanted to learn more about some of the UK's risk assessment and the third National Adaptation Programme, I believe. There's also an independent risk assessment of UK climate risk. The planning is underway for the 4th iteration of that one. So that's it from me. Over. Thank you for your time.
Thanks very much, Hayden, for a lot of information, and I hope that the participants will post some questions for you in the Q&A. We have started the discussion for question 3 in the chat, given that we just have under 10 minutes left. So how could the risks from chemicals and climate change interlinkages be managed? Hayden has given quite a lot of ideas. I've prompted you in the chat to be realistic, and how could it be funded? I think it's easy to put a shopping list together of how to manage. It's much harder to implement it. And Hayden, you're welcome to go ahead and look at any responses, and in the meantime, we'll post the first poll question. So you're welcome. Yeah, over to you.
Okay, just wait a couple of minutes for them to come in.
And so it's a question on the poll, again, using the Menti link for the climate change and chemicals interlinkages. Which sector should take the responsibility for identifying and managing the health risks? You need a driver with these situations. And you're welcome to indicate your responses in the chat as well.
I can see a couple of comments. So I can see one from Jessica. Chemicals and climate change interlinkages could be managed through coordinating a national multifaceted monitoring system. And likewise, a an approach from Sheardath around having a data-driven approach backed up by policymakers. So I think it is recognised more and more now, and it's reflected in some of the agreements, that there is actually a need for us as different sectors and covering the different areas of protection and policymakers, that there is a need to work together better to be able to implement some of these things. And there are examples where many departments come together to work together to coordinate our approaches to various things such as this.
What do you think of the responses that are coming in so far for the poll?
For the climate change, which sector should take responsibility for identifying and managing the health risks? So, chemical sector and climate sector. Yes, I think in reality, this often falls with the governmental sector as taking responsibility. However, as recognised both through the global framework and other international agreements, and I think by the sector itself, this is an all of society approach, and everyone has some role to play in this. Some perhaps you could argue more than others. So, for example, this ranges from governments having policy and legislation to manage the risks to health. It requires industry to be responsible and to operate within those, which of course they do. But it also requires the end user and even down to the public to think about how they use resources and how they dispose of chemicals, etc. So, for example, there are many cases of spills based on releases to the environment that do come from the public. These are not as large and as grand scale as those that come from industry, but they do happen nonetheless, and they do impact on, for example, particularly in the UK, as we get a lot of our drinking water resource from groundwater, they can impact on that. And this might be more of a challenge going forward when water resources become more scarce.
Yeah, there's quite a few comments in relation to the sectors, and also I guess the point to really bring in is the industry's role, and perhaps one thing that we haven't touched on so much is the financing, and both sectors need to collect cost recovery financing from chemicals industry, as well as within the climate change, those who are emitting carbon, who have carbon emissions. But then the question is, does that money filter into the research looking at the climate change and chemicals linkage? And I think that's really an important issue.
Yes, well, it might always be difficult. It might sometimes be difficult to follow exactly the money, but I think the key thing, I think there are lots of incentives for both industry and government to move towards a more health and environmental friendly use of resources, etc. And we've seen that even in the public sphere, for example, about what is going on in terms of climate activities, and to some extent the public pressure exerted in this area. But there are also, and that's why I thought I'd mention it as opportunities earlier. So there's a whole load of risks that need to be addressed, but for many sectors of society, that those might also be opportunities as well.
So we're slowly coming to an end, and I wondered if you want to make any last comments or any last comments on the next poll question that's been put before I close us. Natasha, maybe you can scroll up a bit. So what measures are already in place? I don't know if you've got, Hayden, if you've got one last comment you'd like to make.
But can be done to reduce the risk of a chemical. I think clearly, well, what measures are already in place? So we have, as I mentioned, there are lots of things that, although by their design, they're intended to reduce perhaps property damage, reduce inconvenience and all the other things around flood, for example. They will also help reduce the exposure to chemicals. And likewise, we are aware of the risk these things are posing to waste storage sites. So there are incentives on both sides for example, the industry should consider the risks from climate as well to make their infrastructure more resilient. We've, as part of the research, there's been highlighted the impacts of storm events on oil rigs, etc. But this can also happen on land installations. They can be prone to flooding as well. So there are risks, and this provides, I think this should provide enough incentive. So those things can be taken to reduce release of chemicals, thereby reducing the impact on health. I think because there are so many questions really about what is our exposure, how do we manage it, and can we manage it in relation to the climate change question, that some of those really need answering or examples provided so that the risk will be taken seriously to make the change happen. Because sometimes it would be very difficult to drive large investment without convincing people of the risk. So that's key for us really as researchers to be able to provide evidence of the risks.
I think that's a great note to end on. Thank you very much. So we have come to the end of our time. Very important discussion, and thank you to the three presenters, to Raquel, Tom and Hayden from UK HSA, who've taken us through the HEC report and also their own ideas around the climate change and chemicals linkage. And thank you to all the participants who really were very engaged. And we will spend some time going through your responses. So please make sure that you have signed up for the community of practice. You will then receive the policy brief that I presented at the beginning. That should be coming out very shortly. You will also receive a copy of the digest. There'll be the link to the recording of this section, and you will also get notifications of the next discussions. Thank you also to Natasha and Janice in the background who were making this discussion run smoothly. Also, there was a slide, perhaps you can just go back to the next slide, previous slide, Natasha, just to remind you, if you're interested in UCT's Masters in Chemicals Risk Management, which is an online program, applications close on the 31st of August, and also our Masters of Public Health, which is a face-to-face Masters, the applications will be closing soon as well. There will be an evaluation. We encourage you to please fill in the evaluation. And just to let you know that our next discussion will be on the World Health Organization's chemicals roadmap. They're in the process of updating it, so we encourage you to sign up and join on the 10th of October, again at 2 o'clock. So thank you, everyone. I wish you a good day wherever you are, and let's keep this discussion going. Thank you for your time to all the presenters and the participants. Bye for now.
Thank you.